Good afternoon, gentlemen, or might be good morning. Mr. Novak here, or Mr. Complex, as I have been introduced. But hey, guess what? Yes, I might be doing the complex one, but I'll be using the aid of the calculator. However, I will challenge you some to maybe watch the second video, where I'll introduce how you can do it manually, but that's something you won't have to worry about until year 11 math methods, should you choose to go on there. Right, so let's take a look at what was discussed so far by Mr. Farragut, not Mr. Simple. And that's right, and he talked about the null factor law. Remember, that's when we have a function equal to zero, and when we solve for it, we actually are finding the x-intercepts. Because basically what we're trying to do is we're learning how to go about looking at two particular polynomials and eventually to sketch them. The first of all, of course, are the cubics, and that's the x cubed or the degree 3. Now, cubics, when they are solved, they'll either have 1, 2, or 3 intercepts. Basically, when drawn, you will be shown later on by Mr. Devon, sorry, how to sketch them. He'll most probably show you this option, and when it goes through and draw the Cartesian plane, you'll notice it has 1, 2, or 3. But it is possible that we could have one with only 2, where 1 is a toucher. And finally, we could have the possibility of 1. So with the cubics, you'll either have 1, 2, or 3 possible solutions. As I say, the null factor law will give us the x-intercept. The other polynomial that we're looking at, of course, are the quartics. That's x to the power 4, or the 4 degrees. As a result, they will have either 1, 2, 3, 4, or anyone guess what the other option is? 1, 2, 3, or yes, that's right, no intercepts. In other words, Mr. Davin will also show you, for instance, example, if I was to draw a quartic, we normally might draw it like so. Okay, and as you can see, it's 1, 2, 3, 4 intercepts. So we could possibly have a touch-up, which will give us 3 intercepts. We could have one possibly translated so high that it doesn't cut the x-axis at all, and that is our example of none. See if you can draw the other two options. That's only 1 or 2 x-intercepts. So, of course, for us to be able to work out the solution to cubics and quartics, it would be very challenging. So, of course, for this year, we're just going to rely on our CAS calculator. So, turning to our calculator, remember it's a case of using the calculator page. And I'll just basically demonstrate that to solve this, we'd use menu 3(1) to solve, type up the equation. In this case, it's x cubed. That's x cubed. Oh, let's raise that a little bit. Let me pause for it. All right, that's it. So we have solve for x cubed. That member is the caret to the power of 3. Let's cursor across so we can do minus 7x squared minus 7x squared plus 7x, and finally plus 15 equals 0. In other words, if we let y equals to 0, we are actually finding out along the x-axis the place where the function crosses it. And don't forget, comma x. We're solving for x, and there's our solution. Being a cubic, we have in this example 3 x-intercepts. So yeah, it's just as simple as that. Menu 3.1. Though some of you might want to look at another example. Let's look at a quartic. But I'm also going to demonstrate to you where you might be asked to write the function in its factorized form. So let's recall that because I'm going to have to copy this out a couple of times, I might as well look at using the special defining function. So I'm going to write f1 of x. So f1, you recall this a couple of months ago, I showed you this. Oops, try again, f1 brackets x. So f1 of x, okay, so that's the function 1. Close the brackets. We're using the define button, which is the control, and that button there, as you can see, if you look at your calculator carefully, it's the define, which is the double dot equals. And now I'm going to type in my function, which is 2 times, or 2x to the power 4. So it's a quartic. Cursor across, minus plus 3x cubed plus 3x cubed. Again using the caret. Cursor across, minus 12x squared. Use the x squared button. Cursor across, minus 7x. Minus 7x. Don't forget, as you're writing the constant, remember exercise A was identifying the constant. Of course, when that is equal to 0, that will be our y-intercept. All right, so I just press enter, and that way I won't have to type all that out again. So if we are asked to solve, that will be simply menu 3.1, menu 3.1. All I have to do now is go var. There's the function 1. Select that for the variable x. I think I still have to go comma x. And there's our solution. Okay, what have I done wrong? Oh, I forgot to let it equal to. Yes, that's right, the null factor law. Okay, so that's why it's important to keep it focused on that equals 0. So there's our null factor law. We're trying to find the x-intercepts, and sure enough, there they are. X equals either minus 3, minus 1, positive a half, or positive 3. So it actually intercepts at 4 locations. And we can actually see that if I was to go home, graph, again go var, the function, oops, try again, var, press enter. I'll put in the x value x in there and draw, and there you are, the quartics. Obviously we're missing the bits down the bottom, but as you can see, there's the 4 locations that it cuts it. Of course, if you are asked to do the factorized form of that, don't forget we have that as a feature menu. That's 3 for algebra, 1, 2 for factorize. Again, var, because I already spent the time to define it, make sure it's with respect to x, and let's press enter. And as you can see, Mr. Farrago showed you that each one of these factors needs to equal to 0. So, and shortcut is that it's minus b over a. So the opposite of minus 2 over 1 is positive 2, negative 1, negative 3, and of course this one is 1 over negative 2 becomes positive half. So there you are. That's how we can use our calculator. I'll do just a couple of more examples. Okay, so let's do this one here, or you can try it yourself. That's the question 11. So I'm asking you if you could go and do those as well. And I'll do one other one, an x cubed one. So let's just do a quick x cubed one. It won't take me long. I'll do that bottom one minus 10x minus 12x using our calculator. I'll make it a bit larger so you can see it properly. Oops. Okay, so we go solve. We go straight to solve. So it's menu 3.1, menu 3.1. So that's x cubed. Pause that. So that's raised to the power of 3. And we had plus x squared minus 12x. Oh, it was a minus 10x, wasn't it? Yes. Backspace, 10x. Minus 12. Well, I hope that was the right one. Don't forget to let it equal to 0 because it's a null factor law. And we're solving for x. And pressing enter. And as you can see, this time it's a cubic. We have our three intercepts, but clearly we have a third factors as well. Because if you watch my next section where I show you how to do this manually, this will actually factorize to a single product like x plus 3, and the other one will be a quadratic that cannot be factorized. Oh, one option is, of course, is for me to do the menu factor. So menu, algebra, factorize. Let's copy that down, press enter, delete the solve. There's another option you've got there. Press delete the and enter, and there you are. As you can see, that cannot be factorized easily unless you use the quadratic formula. So there you have it. We can easily do it with our calculator. Next year you'll have to do it manually or watch my video, which is a second option. So can you do the exercises, including questions 9 and 11? A little bit extra, but as you can see with the aid of the calculator, not a bother. Have a good day.